Alright, today we're going to be talking about Chapter 10, Lesson 3. This is all about mean absolute deviation, or you can be abbreviated as MAD or MAD. So, mean absolute deviation, what this represents, or what this means, is the average distance between each data point and the mean of the data. So that's a lot of stuff, and it's actually a pretty labor-intensive process, but it's not difficult. So first of all, we have to find the mean, which means we add up all the numbers. There are 6 of them here. We add those up, and then we divide by 6. So we want to look at 9.5 plus 9 plus 8.25 plus 9.25 plus 8 plus 8.5. And that would give us 52.5. If we divide that by 6, then our mean would be 8.75. Now, what we need to do is we need to find the difference from each value and the mean. So the first one would be 9.5 minus 8.75, and that's 0.75. Next one would be 9 minus 8.75, and that would be 0.25. Next one, because we're looking for the absolute value, we'd be looking for 8.75 minus 8.25, and that's 0.5. Next one is 9.25 minus 8.75, and that's 0.5. Next one is 8.75 minus 8, and that's 0.75. And then the last one is 8.75 minus 8.5, and that's 0.25. So these 6 values are the values that we're going to use to calculate the mean absolute deviation. So now when we find the mean of the differences, we're going to add those 6 values together. And if I do that, 0.75 plus 0.25 plus 0.5 plus 0.5 plus 0.75 plus 0.25, I get 3. 3 then divided by 6, because there are 6 values, is 0.5. Now, what this represents, what this 0.5 represents, is each price, because we're talking about movie prices, is on average and because we're talking about dollars, $0.5, 50 cents from the average. This helps us to determine a measure of variability. So we use the mean absolute deviation when we're talking about the mean. So let's look at another example here. Example 2, compare variation. So, first one, Katie's heart rate versus Danielle's heart rate. So, when we go through this, we want to find the mean. So the first number we'd be looking at is 63. And then we have 2 65s. We have 3 66s. We have a 70, a 71, a 73, and a 75 for a grand total of 680. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, which means that the mean is 68 beats per minute. If we look at Danielle's, we have a 67, a 68, 2 70s, a 71, 2 72s, 2 73s, and a 74 for a total of 710. Still 10 values, so we have 71 beats per minute. So just looking at this right now, Danielle's heart rate is faster on average than Katie's. Well, now let's look at the mean absolute deviation. So we have 63 is our first one. So 68 minus 63 is 5. We'll then do 68 minus 65, and that's 3. We have 2 of those. We have 3 66s. And then we have a 70. So we're going to do 70 minus 68 is 2. We have a 71. Make all these equal signs here. We have a 73. And we have a 75. So if we find the mean of all of these numbers, 5 and 3 and 3, and those 4 2's in there, and then another 3, a 5, and a 7, we have 34 divided by 10, so it's 3.4 is the MAD. If we look at Danielle's now, we have 71 minus 67, that's 4. 71 minus 68, that's 3. We have 2 70s. We have a 71. We have 2 72s. We have 2 73s. And a 74. We add all these numbers up. We have 4 and 3 and 1 and 1 and 0 and 1 and 1 and 2 and 2 and 3. That equals 18. Still divided by 10, we have 1.8. So now what this means is that Katie's heart rate is lower on average, but Danielle's has less variance. It doesn't vary as much. Danielle's can go up or down a little bit more based on her average, but Danielle's doesn't. So what we would say is Katie has a lower heart rate, and that's on average, than Danielle. But has more variance. And what that means is Katie has a lower heart rate, but it fluctuates a lot more. It changes a lot more. It could go up, it could go down significantly more. So, that's the end of Lesson 3. If you have any questions, please let me know.